kinematics, we will study motion of the object, but we will not consider the reason for motion. This is very important, and this is what we are discussing in this entire chapter. We are discussing kinematics. So kinematics means here we will study the motion of the object without considering the reason for motion. Reason means which force is responsible for motion or who is causing that force. That and all we will not consider. We will consider where it is moving, how, with what speed it is moving, in which direction it is moving. That all we will study. But the reason of the motion we will not consider. Is that clear?
Yes, sir.
So we are dealing with kinematics. Kinematics means motion we will study, but the reason for motion we will not consider. Okay, you can note down this. This kinematics is important. Now let us see some types of motion here. Are you able to see this?
No, sir.
No, sir.
Maybe some. Wait.
Yes, sir.
Wait. I will show. I will show it in other place. Wait a second. So we are dealing with kinematics. Let me show you a video of the motion, different types of motions. Just a second. Is it visible now?
Yes, sir.
Okay. Now, here you can see a motion. So, what actually is happening is, you consider the 2 points here, A and B. The ball is moving from A to B. So, what actually happening here is the change in position. When any object changes the position with respect to time, we can say it is motion. Now, what are the types of motion? A rectilinear motion. What is a rectilinear motion? As you can see here, if the object is moving in a straight line, it is called a rectilinear motion. Another type of motion is circular motion. Circular motion, you are familiar with circular motion. If any object is moving along the circumference of a circle, it can be considered as a circular motion. Another one is a rotational motion. I am just giving some examples of types of motion. Then we will categorize all this. Okay. So rotational motion means a motion of a body about an axis. For example, this fan. Fan is rotating about an axis. This is an example for rotational motion. Another one is called a periodic motion. Periodic motion means any motion which repeats after regular intervals of time. For example, the pendulum in your clock or the motion of earth around the sun. These all are examples for periodic motion. Now, are you able to see a car here?
Yes, sir.
What type of motion it is showing?
Circular motion.
Any other type? So it is showing both circular motion as well as periodic motion. So at a time, object can have more than one type of motion. Now, okay. So these are the some examples for motion. Now let us come to our main point. The concept of a point object. So far, we are dealing with the point objects only. Can anyone tell me what is meant by a point object? Any idea? Don't just passively listen. You just interact. Just try to answer. Why don't you keep your cameras on so that I can also see what you are doing? You are having class or you are doing something else. Can anyone tell what is the concept of a point object? Don't read from there. Okay. Point object means if the size of the object is less compared to the distance traveled by it, it can be considered as a point object. My question is this ball? Are you seeing the ball?
Yes, sir.
The ball can be considered as a point object or not?
Yes.
Yes, ball can be considered as a point object. So we will feel that if the size of the object is less, then only it can be considered as a point object. Now, what about this one? What is this? What is the second
Ah.
object? Whether it is a point object or not.
No.
It can also be considered as a point object. So when we consider the journey from here from southern end of India to north end, that is a long distance. When we consider that journey, this star can also be considered as a point object. So the point is that with knowing the size of the object, we cannot say that it is a point object or not. Next, what is this?
Aeroplane.
Okay.
Is it a point object? Is the flight is a point object? It can also be considered as a point object. Now the next one, it is a big ship. It can also be considered as a point object. So point object does not depend on the size only. It depends on the distance, how much it is traveling. Now the best example of a point object. What is that?
Earth.
It can also be considered as a point object. Clear? When we consider the solar system and all, Earth can be considered as a point object. So this is the concept of point object. Clear? So point object, if you want to say about an object, whether it is a point object or not, you should know the size of the object and you should know how much distance it is traveling or where you are considering it. That is the concept of point object. In this chapter, we are dealing with the point objects. Now, about rest and motion. Can anyone tell me what is the condition of rest?
No motion.
No motion. Okay, I will show you an example. I am having a bottle here. I kept the bottle here. Whether is it in motion state or rest state?
Rest seat.
Rest. Rest.
All of you have same opinion?
Yes, sir.
Okay. Sure. Any other opinion? Are you seeing my bottle?
Yes, sir.
Yes, sir.
Are you able to? Uh, it's a good one. Is it a rust? Sure. Okay. Now listen carefully. I am seeing the same bottle. Don't ask me how you are seeing, but I am seeing the same bottle sitting here, and I will say that it is at rest. Now I will go to moon. Don't ask me how you are going. I will go to moon and see this bottle. I can see. Now that will be in rest or motion.
Rest. But you will be seeing in motion.
Say because Earth is also moving. So this rest and motion terms are comparative. Okay, that point we will discuss now. See, rest and motion. This is a ball, and this is a car, and a stationary person is observing it. Now look at the screen. Screen visible to you?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. You can see a ball there. You can see a car there, and a stationary person is observing that. Now, according to that person, or with respect to stationary man, the ball is at rest. So we cannot generalize and say that the ball is at rest. With respect to that stationary person, the ball is at rest. Whenever we are saying the rest or motion condition, we have to say with respect to what. And with respect to that man, the car is also at rest. Clear? So the point here is when we are saying the rest, we are saying with respect to whom. That with respect to whom is called the frame of reference. That frame. Now, ball is moving with respect to that stationary man. Previously it was at rest. Now the ball is moving with respect to the stationary man. The car is also moving with respect to the stationary man. So whenever we say motion or rest with respect to what, that you have to specify. Now, examples. The object at rest. Okay. Normally we will say with respect to our surface only. The buildings, mountain, these all are at rest. With respect to the surface of earth. Motion examples you already know. Okay, car, bus, these and all are examples of motion. Now, coming to the main point, let us see an example here. A stationary man is there, one car is there, that is in motion with respect to stationary man. Clear? Is it visible?
Yes, sir.
Yes, sir.
This car is in motion with respect to that man. Now we bought second car. This car is also in motion. Now we are having both the cars. Now listen here. This upper car we can call it as A. This lower one we can call it as B. Now what happens is that both the cars will move. So with respect to that person, both the cars will be in rest or motion.
Motion.
Motion, sure. Now imagine that both are moving with the same speed and driver of the car A is looking to the car B. Then they will be in motion or not? Once again, imagine that these two cars are moving with the same speed like this. Two cars are moving in the same direction with the same speed. The driver of the first car looks at the second car. Then the car will be in motion or rest. That is my question. Just say an answer. Anyone? Wrong also, no problem. You just interact so that I will be able to see that you people are there. No answer. Just try to interact. So according to that man, both the cars are in motion. Now both the cars are moving with the same speed. The driver of one car sees the other car. That will be in motion or rest.
Rest. But it is in motion.
No. Uh, okay, fine. I got it. So that will be in rest only. Because, why? Because, listen here, see here, when both are traveling in the same direction with the same speed, there is no change in motion with respect to one another. You see here, they are together now. Till the end, they are together only. But for the man, initially they are in front of the man. Now the position changed. Okay, but for both the cars they are together in the starting. Now also they are together, every time they are together only, so there is no relative change in position. So when both the cars are in motion, with respect to one car, another car will be at rest. That is the point of the concept. Motion and rest are relative. Okay, now when we are going to space and you observe anything on earth, all will be in motion because our earth is moving. Now let me ask you one thing. So what is this?
Earth.
Earth. And in earth we have sea, and one ship is there. Ship is moving in the sea. Clear? And the question is, read the question, or let me read for you. A ship is sailing in the ocean. A ship is sailing in the ocean. A man, his name is A, in the ship is running on the board in the direction opposite to the direction of motion of the ship. Okay, a person is there on the board of the ship. His name is A. He is running in a direction opposite to the direction of motion of the ship. Another man B is standing and watching man A. Now, question for you is, you have to say whether rest or in motion. Man A with respect to man B, it will be rest or motion.
Motion. Motion. Motion.
Motion. And B will be
Motion, sure.
motion.
Sure. Good. Okay. Man A will be motion because man A is running on the board of the ship in a direction opposite to the motion of the ship. Now the second question. Man A with respect to ship.
Motion.
Motion or rest? Any other answers?
Rest.
Your name is Nima. Okay. Rest. Any other answer? One motion answer I got, one rest answer I got. Remaining 40 people are keeping silence.
Motion.
Motion.
Motion. Who is it? Anisha, what is your answer, Anisha?
Motion.
Motion. Okay. What is your answer, Parvati?
Motion, sir.
Motion. Okay, so it is as simple as that. It is in motion, no doubt. Because, or compared to the ship board, the man is running. So it will be motion. Next, man B with respect to ship. Fast.
Rest.
Motion or rest?
Rest.
Rest. Rest.
Okay, so this you are having, all are having same answer, rest. So absolutely right, rest. Next, ship with respect to still water.
Motion.
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 Motion. Motion. Motion.
Nima. No idea. All are having motion. Absolutely right. That is in motion. No problem. Next. Man A with respect to still water. Think carefully and tell me the answer. Man A with respect to still water. In motion or rest?
Motion.
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 Yes.
All are having same answer. Man A with respect to still water. Now imagine that. Listen, ship is moving towards left, and man is running towards right because it is written in the question that the man is running on the board in the direction opposite to the direction of motion of ship. So ship is moving towards left, and man is running towards right. And imagine that both are having same speed. Then with respect to the water, whether the position of the man will change,
No.
No.
then how he can be in motion? So here in this case, man A with respect to still water, we can say that if the ship and man are having same speed, then the man will be at rest. If it is not like that, it will be in motion. Now next, man B with respect to still water.
Rest.
Nima, rest.
Motion.
Who is motion? Anyone else? You all are from Kerala, Janvis?
Yes, sir.
Yes, sir.
All. Then why you are not responding? You should respond more. Arti, open your mic and speak. Don't just type. പറയുന്നതൊക്കെ മനസ്സിലാവണില്ലേ?
ഉണ്ട് സാറേ.
സാറ്
That
മലയാളം
also no response. എന്നാ respond. ഞാൻ മലയാളം പറഞ്ഞു. That's it. Okay. So man B with respect to still water. Someone of you told that it will be rest. Some of you told that it is in motion. Now the right answer, it will be in motion because the ship is moving and he is standing on the floor of the ship. So he is moving along with the ship. So with respect to still water, the man B is in motion. Next, ocean with respect to earth. Say, I have so many options like this. Ocean with respect to earth. All gone. What is the answer, Parvati?
rest.
Rust. Anisha, what is the answer? You can see some names here. Nima, what is the answer?
Are tidal waves included?
Which one? I can't hear. Can you repeat?
Like without any tidal waves?
No need to consider tidal waves or the all. You can consider the ocean as a still water. Ocean means we are not saying about the water only. Entire ocean we are speaking.
Motion. Rest.
Okay. The ocean, inside the ocean, the water is moving. Not considered like that. The waves and all you don't consider. You consider ocean as a single part. Then it will be at rest. Ocean with respect to earth, it will be at rest because we are considering it as a single or still water. Next, ocean with respect to sun.
Motion.
Motion. Motion.
Exactly. It is in motion because Earth is moving. So whatever there present on Earth, that all will move. Next, Earth with respect to Sun.
Motion.
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 I can go on asking like this. Next, with ship with respect to Sun.
Motion.
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 The Sun with respect to Milky Way galaxy.
Motion.
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 So like that, we can go on asking like this. You also, what you have to do is take different cases like this and analyze yourself whether it will be in motion or rest. Okay. That is the next one. Milky Way galaxy with respect to other galaxies.
Motion.
Motion.
Like that, we can go on asking. Clear. So this is the concept of motion and rest. So the main point here is that the motion and the rest are relative terms. We cannot say that an object is motion without knowing the frame of reference. Clear?
Yes, sir. Yes, sir.
മനസ്സിലായോ?
Yes, sir. Yes, sir.
Okay. Okay, good. So now motion in 1, 2, or 3 dimensions. You have any idea about one-dimensional motion?
Motion along a straight line.
Yes, exactly. Motion along a straight line. It is one-dimensional motion. Can anyone tell me an example for one-dimensional motion?
Free falling body.
Exactly, good. Freely falling objects are having one-dimensional motion. Example, if a mango is falling down freely, it is having one-dimensional motion. Any other example? I'm asking a general question. It is there in 9th class, I guess. You all completed 10th just now, no?
Yes, sir.
11. Yes,
Waiting
sir.
for the result.
Yes, sir.
It will come soon. Don't worry. Maybe in a week. Let us see. Now, tell another example for this motion in a straight line. Just try to say. What about the motion of lift? Is it one-dimensional?
Yes, it's a one-dimensional motion.
Exactly. Motion of lift. And if the car is moving on a straight highway, we have to specify the straight. What about motion of light?
One-dimensional motion.
Light. Correct. So this is one-dimensional motion. It is motion along a straight line. Okay. And if we speak in the terms of coordinates, we have 3 coordinates. What are they?
X, Y, and Z.
X, Y, and Z. Among these 3, if only one coordinate is changing, it is one-dimensional motion. Now coming to two-dimensional motion. Two-dimensional motion means it is motion in a plane or any surface. Examples, please.
Circular motion.
Examples. Correct. Alfia, good. Circular motion is an example for two-dimensional motion. Any other?
Oscillating motion.
Projectile motion.
Oscillation is two-dimensional. Next. Someone else was saying something. I'm not able to hear that. What about our walking? When we normally walk, is it one-dimensional, two-dimensional, or three-dimensional?
Two
When we are
dimensional.
walking, Whether it is one dimension, two dimension, or three dimension. Two dimensional because we are moving in the surface only. Okay. Now here in two-dimensional motion, two coordinates will change. Now coming to three-dimensional motion, it is motion in space, and all the three coordinates will change. Examples?
Motion of a bird.
Motion in space. Say example. Yes, bird flying is an example for three dimension. Then more examples, please. So many are there.
Motion of a aeroplane.
Aeroplane. Next. Motion of kite, motion of fish. These all are examples for three-dimensional motion. Now, take this simple thing. We have three possibilities. We can go left or right. That is one case. Second, we can go front or back. And what is the third option? We can go up and down. So left to right, front back, up and down. Among these three, if only one is there, it is one-dimensional motion. If two is there, it is two-dimensional. And if all the three are there, it is three-dimensional. Let us take the example of lift. Which motion lift is having among these three? Left, right, up, down, or front, back?
One dimension. Up, left or right?
Now, among these three, lift is moving left to right.
Up and down.
Up and down. Lift is having only this up and down motion. Lift can move up or lift can move down. When we normally walk, what all things we have? Left, right, up, down, front, back. Among these three, which all things we are having when we are normally walking? We can walk front to back.
Left to right.
Front, back, and left, right. So it is an example for two-dimensional motion. When you are playing football, the motion of the ball, 1D, 2D, or 3D?
3D. 3D.
3D. Because it can go front, back, it can go left, right, it can go up, down also. So in this manner, if you have any motion, you can identify like this. Okay. Now tell me, you think carefully and tell me the answer. I have a distant target. Okay. My enemy is standing at a faraway place, and I took my gun and I am firing at him. Okay. He is standing at a faraway place. Okay. And I am firing at my enemy. I fired the gun. Bullet is going. The motion of the bullet will come in which category?
1D.
1D, 2D, or 3D? Sona, what is the answer?
1.
Not able to. Ayana, what is your answer?
Sir, in science camp, the upper limit.
Alfia.
So KP visit was included.
Anisha.
1D.
Nia. 1D. Nia. I think this all kept the phone and gone. Bhagyalakshmi.
Okay.
Sona Simon 1D. Okay. Abhirami.
KP visit ఎందుకంటే ఇక్కడ లిమిట్ KP visit కి మీరు only 33,000.
Okay. So tell me, Aryananda 1D. Okay. Aryananda 1D, Sona Simon 1D. Any other answer other than 1D? Now listen carefully. You tell me the answer. I am standing on the seashore. Have you seen a beach? All of you gone to beach?
Yes, sir.
You are standing at a beach. Okay? And facing the sea, you are firing your gun. You are seeing the facing the sea, you are firing your gun. How the bullet will go, or where the bullet will go? You just imagine you are at the
Into
beach and in front of you sea is there, and you are facing the sea and firing. Where the bullet will go?
into the seawater.
It will travel straight line like this for a long time, then it will fall down. Clear? So this is a good example. The motion of bullet cannot be considered as one-dimensional motion. Of course, it is one-dimensional motion if it is a short distance. I specifically told that my enemy is at a faraway place, so it is having more distance. So it cannot travel straight for a long distance. It will curve, bend from the path. So it is example for 1D or 2D or 3D. Two-dimensional motion. If it is a faraway place, it is example for two-dimensional motion. Okay. Now you might have heard that when soldiers are aiming at a distant enemy, if they want to fire at the heart, they will aim at a higher position. If the bullet has to hit here, they will aim somewhere here, so that the bullet will curve and go and hit at the place. Okay, leave it. So these are the examples for one dimension, two dimension, three-dimensional motion. Now we are discussing about motion in a straight line. First, let us see a case here. A man is there. Are we able to see him?
Yes, sir.
Sir.
Yes, sir.
Yes, sir.
He is traveling like this. How much he traveled totally?
7 kilometers.
7 kilometers.
Okay, 7 kilometers. So are you able to see his path?
Yes, sir.
Starting from here, he is going 5 kilometer, then 2 kilometer. So the length of the path traveled by that person is traveling a particular path. The length of that path is known as distance. You might have been familiar with distance and displacement in 9th class. Have you studied in 9th class?
Yes, sir.
Yes, sir.
Same only, but we will deal with a higher level. That is the case. So the length of that path, 5 plus 2, 7 kilometer. That is the distance. Clear? So distance traveled by this person is 7 kilometer. Now second case. Wait. You have to travel how much he is traveling. You have to tell me how much he is traveling. Shall I ask him to start motion?
Yes, sir.
Shall I tell him to start? Okay, you look carefully. You start your motion, my dear. Starting. How much distance he traveled?
10 kilometers.
10 kilometers.
You want to see once more? Okay. Others also respond. Two, three responded. What about others? Okay. So here it is clear. Towards right he is traveling 5 kilometer. After that he is coming back again 5 kilometer he traveled and reached at the initial position. So from where he started he returned back to the position, and total he traveled 5 plus 5, 10 kilometers. So this is distance. The important point about distance, it is a scalar quantity. Scalar quantity means it is not having any direction. Clear about distance?
Sir. Yes, sir.
Okay. Good. Now the next term, displacement. Again going back to ninth class. Let us ask him to walk again. Where is my friend? Yes, he came. Shall we start the motion?
Yes, sir.
Yes, sir.
He started. What is the distance here?
7 kilometers.
7 kilometers. Now displacement means we have to draw a line from a straight line from initial point. This is the initial point to the final point. Okay, that will be the displacement. You can see a line there. This line represents the displacement. So displacement in two manner we can say. It is the straight line distance from initial point to final point. Or else it is the minimum distance between initial point and final point. Can anyone tell me how much it will be? How to calculate it? Okay. So when we calculate it, 6.57 kilometer. Now the second case, this you have to answer. Again, he came. He starts his motion. Look carefully. He is going. 5 kilometer, then coming back. Two questions. What is the distance?
10 kilometers.
Question number 1. What is the distance?
10 kilometers.
Good, correct. Question number 2. What is the displacement?
0.
0. Because the initial point and final point, displacement is 10. Who is that message? Displacement won't be 10. Distance is 10. Displacement will be 0 because he reached back the initial point. To calculate displacement, we need only two things: initial point and final point. How he is going, through which path he is going, that and all not at all important. From where he started, where he finished it. Draw a line from starting point to finishing point. That is the displacement. So when it is coming, he is coming back means displacement will be 0. And the important point is displacement is a vector quantity. Vector quantity means displacement is having direction. Clear? Distance is a scalar quantity, whereas displacement is a vector quantity. And as a vector quantity, displacement can have negative values also. Scalar won't have negative values. Vector will have negative values. About scalar and vector we will deal in the next chapter also. Just understand that displacement is a vector quantity, whereas distance is a scalar quantity. Now, a final illustration for distance and displacement. Okay? Are you able to see the ball?
Yes, sir.
Okay, let me throw the ball then. Let me throw the ball. I thrown the ball and it is going like this. I am naming that path as ACB. What is this ACB?
Distance.
Distance. It is written there also. Now, when I draw a line, straight line from A to B, this is the displacement. Look like a bow and arrow, bow arrangement. Okay. So the straight line is displacement. Clear? Now let us compare these two. Distance is a scalar quantity, whereas displacement is a vector quantity. Distance traveled by a moving body cannot be 0. displacement can be 0 or negative also. Okay, so this point you have to remember. Now, I want an answer for this question. Are you able to read it? An object is traveling in a circular path of radius 10 meter. If it completes 3.5 circular motions, what is the distance and displacement? I am giving you 2 minutes time. You have pen and paper? Better to try. Solve this and tell me the answer. What is the distance and displacement? Any answer? An object is traveling in a circular path of radius 10 meter. If it completes 3.5 circular motions, what is the distance and displacement? That is the question. Anyone? How many? If you got distance, displacement or distance, anyone also you can say the answer.
Sir, displacement 20 meter.
Okay. Displacement 20. Harshita Arun. Okay. And now distance, sir? Distance, anyone? No distance. Okay. So as we know, finally it starts from a point on the left side and it will reach on the right side. So the distance displacement will be equal to the diameter. Displacement will be equal to the diameter, and the distance will be equal to, for one circular motion it is 2 pi r. So 3.5 into 2 pi r. What is the answer? That will be equal to 219.8. Okay. Around 220. Harshita, 219.8 or around 220. That is right. So that is all about distance and displacement. Okay. Now we will discuss 2 more topics today. Then we will stop for today session. So this is an important concept: is speed. Can anyone tell me what is speed?
Distance traveled in a certain time.
Exactly. Correct. So to calculate speed, we need to know 2 things. First one, how much distance it is traveling, and second one, in what time it is traveling. So 2 things are important. One is how much traveled, and second one is the time taken to travel. The rate of change of distance is called speed. The equation for speed is distance traveled divided by time taken. Okay. If the distance traveled we are taking it as s divided by t, that will be equal to the speed. Now, as the distance is a scalar quantity, Time is a scalar quantity. The speed is also a scalar quantity. So remember these 2 points. Distance is a scalar quantity as well as speed is a scalar quantity. The unit of speed is meter per second. Sometimes you might heard the unit. Which unit you are familiar with? Unit of speed. Much familiar with kilometer per hour. Okay, kilometer per hour. That we normally use to express the speed of vehicles and all. That is also a unit of speed, but the SI unit is meter per second. Now, what is meant by uniform speed? Uniform speed means, look here, you can see a car here. It is covering equal distance in equal intervals of time. For example, the first 10 meter, it covered in 5 seconds. Then the next 10 meter, again it will cover in 5 seconds. So in every 5 seconds, it is covering 10 meter. I am saying for an example. Like that, if equal distance is covered in equal intervals of time, we can say that the object is in uniform speed. Clear? Uniform speed means equal distance in equal intervals of time. Now moving to the next case, there is variable speed. Can anyone tell me what is variable speed? Speed will be variable. So that means unequal distance in equal intervals of time. For example, in the first 5 seconds, it traveled 10 meter. And in the next 5 seconds, it traveled 20 meter. Then it is an example for variable speed. First 5 seconds, 10 meter means what is the speed? First 5 seconds, the car traveled 10 meter.
2
Correct,
meter
2
per
meter per second. Next 5 seconds, it traveled. Correct. Next 5 seconds, it traveled 20 meter. What is the speed?
4 meter per
4 meter
second.
per second.
Exactly. So the speed is varying. That is called a variable speed. You can see the car here. Initially, it was start moving slowly. Then its speed increases. This is an example for variable speed. So uniform speed and a variable speed. Now, average speed. Average speed means in a journey, if the object is traveling with a different speed, in a particular journey, if the object is traveling with a different speed, we will calculate the average speed. How to calculate the average speed? The total distance traveled divided by total time taken. How much total distance it is traveling divided by what is the total time taken. That is called the average speed. To find average speed, we are having different equations in different cases. Okay. One or two I will say here remaining. When we are doing numericals, we can find. If a particle covers first half of the total distance with a speed a, first half with the speed a and the second half with the speed b, then average speed will be 2ab divided by a plus b. This we can find while doing numericals. Okay, some important cases only I am saying here. And the second case is first 1/3 with the speed a, second 1/3 with the speed b, and third 1/3 with the speed c. Then 3abc divided by ab plus bc plus ca. Okay. Now we have called something called the instantaneous speed. Okay. What is meant by the term instantaneous speed?
Speed of object at
Okay.
any
For
particular
example,
instant.
any correct. Speed of object at any particular instant. Okay. Let us take an example. Say some places in Kerala. Any two places you say? Say any one place name.
വയനാട് കോഴിക്കോട്
Wayanad, Kozhikode. Let us imagine that I am traveling from Wayanad to Calicut. Okay. In between which route we will go? In between which place will come? Okay, we will leave it. Wayanad we will leave it. We will take the highway. I am traveling from Kasargod to Calicut. Kasargod, you know?
Yes, sir.
Don't know. Kasargod to Calicut I am traveling. So from Kasargod to Kannur, my speed is 80 km per hour. Clear? Listen carefully. I am traveling from Kasargod to Calicut. Kasargod to Kannur, my speed is 80 km per hour. Same speed I am traveling in a car. Don't ask me how you are able to travel, traffic jam and all that and all. I don't know. Okay, I can travel. So from Kasargod to Kannur, my speed is how much?
80 kilometer per hour.
Forget. Then Kannur to Calicut, my speed is 100 km per hour. Clear? So my question is, what is my speed from Kasargod to Kannur? Answer. I have three questions. First question, what is my speed from Kasargod to Kannur? Tell me. Not able to get it. Okay, again let me see. Are you able to hear?
Yes,
Yes,
sir.
sir.
Are you? Then listen carefully. I am traveling from Kasargod to Calicut. Kasargod to Kannur, I am traveling with a speed 80 km per hour. And Kannur to Calicut, I am traveling with a speed of 100 km per hour. Is it clear? Now you have to answer 1, 2, 3, 4 questions. What is the speed from Kasargod to Kannur? Question number 1. Your answer?
80 kilometer.
No doubt 80 km per hour because in the question itself I told. Second question. What is the speed from Kannur to Calicut?
100 kilometer per hour.
100 kilometer per hour.
No doubt 100 km per hour. Now my question is, what is the speed from Kasargod to Calicut? What is the answer? I told 4 questions after 2 over. This is the third one more pending. What is the speed from Kasargod to Calicut? 100, 80, 90. What is the speed? 180. Nice. That speed is called average speed. That you have to calculate. We cannot say directly. First, we have to calculate the total distance divided by total time. Now, the important question, listen carefully. What is my speed when I reach exactly at Kannur? What is my speed at Kannur? You know the speed from Kasargod to Kannur is 80. Kannur to Calicut is 100. What is my speed at Kannur? Is it 80? Is it 100? That speed is called the instantaneous speed at a particular instant. So here we introduced the 3 speeds. Normal speed, then average speed, then the third one is instantaneous speed. Instantaneous speed means it is the speed at a particular instant. Clear? We will discuss about it. Let me see the graph first. This is a position time graph. Are you able to see it? Are you able to see the graph?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Now, if the position time graph is like this, a horizontal line, it represents that the time is changing, but there is no change in position. That means what the object is doing,
At rest.
the at
It is
rest.
at rest.
Object is at rest. Now, next one.
Uniform
You can
motion.
see here when time is increasing, according to that position is also increasing. With the time, position is also increasing, or according to according to the time, the position is changing. So how much time is changing, according to that the position is also changing. So we can say that it is in uniform motion. Now the next one, you can see sometimes when time is increasing, the position is increasing. Sometimes it is decreasing. It is not equally changing. So we can say it is in non-uniform motion. Is it clear?
Yes, sir.
Yes, sir.
Yes,
Is
sir.
it clear? Okay. Now we have so many cases here. Next term, let it be the final topic for today. Velocity and related cases. Velocity. So tell me, what is velocity?
Displacement of an object at a certain time.
Exactly. Displacement per unit time. What is the displacement divided by how much time taken for that displacement? That is velocity. The time rate of change of displacement of a particle is called velocity. How much displacement the object is having divided by time taken for that. Velocity is equal to displacement divided by time taken, or S by T. Now you can see an arrow mark on the top of V. What does it represent?
It's a
Vector.
vector point.
Are you familiar? Exactly. It is a vector quantity. Velocity is a vector quantity. Vector means it is having direction. It can have negative values. Okay. So this is the difference between speed and velocity. Speed is a scalar quantity. Velocity is a vector quantity. Unit of speed is same as that of velocity, meter per second. We are having another unit called kilometer per hour also. This conversion, you remember, 1 meter per second is equal to 18 by 5 kilometer per hour, or 1 kilometer per hour equal to 5 by 18 meter per second. And sometimes we had to change the unit. Then you can use this. This already you studied in 9th class, I guess. Have you studied this?
Yes, sir.
No answer. Good, Nima. Now, as we discussed about uniform speed, we are having uniform velocity also. If the object covers equal displacement in equal intervals of time, it is uniform velocity. If the object covers unequal displacement in equal intervals of time, it is non-uniform or variable velocity. Now, what will be the equation for average velocity? Anyone?
Total displacement by total time interval.
Exactly, correct. Total displacement divided by total time taken. Total displacement divided by total time taken is the average velocity. Now, that is same only. As we already told, we have uh, we have some equations to find the average speed. Similarly, we have some equation to find the average velocity also. First case, if the particle undergoes a displacement s1 along a straight line in time t1 and displacement s2 in a time t2, then total displacement will be s1 plus s2 divided by t1 plus t2. And the next case, if a particle undergoes displacement s1 along a straight line with velocity v1 and a displacement s2 along a straight line with velocity v2, Then S1 plus S2 into V1 V2 divided by S1 V2 plus S2 V1. This we can note down and we can use this while solving numericals. And if the first half is traveled with a velocity V1, second half with a velocity V2, then 2 V1 V2 divided by V1 plus V2. T1 time with velocity V1, T2 time with velocity V2, then V1 T2 plus V2 T1 divided by T1 plus T2. Now the case half time with velocity V1 and remaining half time with velocity V2. Normally, if we have two velocities or two things, in order to find the average, what we will do is we will add them and divide with 2. That we can do in the case of velocity only in one case. That is, half time it is traveling with a velocity V1 and remaining half time it is traveling with a velocity V2. Then V1 plus V2 divided by 2. Now, let us see the velocity from our graph. This is our position time graph. Okay. I'm taking 2 points here. One point P1 here, which is having coordinates, position coordinate x1 and time coordinate t1. Another point P2 I have taken, which is having a coordinate of position as x2 and time as t2. Now I want to find the velocity of this object between point P1 and P2. Can anyone tell me how to find it? How can I find the velocity of the object between point P1 and P2? Any idea? Are you
x2
able to
minus
see the
x1
points
by
there?
t2 minus t1.
Correct. On. Good. So there is something called the slope of the graph. This straight line distance in red is the displacement there. Okay. So here if we find the slope of this graph, that will represent the velocity. Slope means a change in y coordinate divided by change in x coordinate. Okay. So here it will be x2 minus x1 divided by t2 minus t1. Now something for you. What does it represent? A graph. Identify. We already discussed it. You can see a position time graph. My question is, what does it represent?
Object
See that and tell.
For stationary object.
Object. Object is at rest, stationary object. What does this represent?
For uniform motion.
Uniform motion. It represents uniform motion. Now, what does this represent? See that uniform motion, I made it just in reverse ulta.
Negative
Anyone?
To rest.
Yes, one by one. Nima, please answer.
The speed is decreasing with the time.
Speed is okay, fine, okay, good. Alfia,
negative velocity.
okay, fine. Both are same. It is having a negative velocity. Negative velocity means when the velocity is decreasing, coming towards zero. Okay. So from the graph, we can find these cases. Let me show you something. The difference between speed and velocity. For your school exams, this is an important question. distinguish between speed and velocity, compare and contrast between speed and velocity. At least for 2 marks it will come. So shall we write 2-3 points here? First, the definition. Speed is the rate of change of distance. Velocity is the rate of change of displacement or displacement to time. Speed is a scalar, no direction. Velocity is having direction. Speed of the body can be positive or zero, whereas vector can be positive, negative or zero. Average speed of a moving body can never be zero, an important point. Average velocity of a moving body can be zero. Can anyone tell me an example for the fifth case? That is, average velocity of a moving body can be zero. Can any of you tell me an example for this situation? Where the average velocity of a moving body can be zero. Any example for that situation? Just try to say. No answer. Why you are hesitate to say? So many are there now. Okay, for example, a train is moving on a straight track. It is traveling from station A to station B and then coming back. Station A to station B, the train travels with 80 km per hour. And B to A return, it travels with 100 km per hour. What is the average velocity? Station A to station B, 80 km per hour, returning from B to A, 100 km per hour. What is the average velocity?
0.
Exactly zero, because total displacement is zero. Started from A and finally came back to A. So total displacement is zero. So total displacement zero means the average velocity will also be zero. So that is an important point. Average speed of a moving object cannot be zero, whereas average velocity of a moving object can be zero. Yeah, that is an important point. Now, the instantaneous velocity. As we already told about instantaneous speed, we have instantaneous velocity also. Instantaneous velocity means the velocity at a particular instant of time, a particular instant. As I told, we are moving from Kasaragod to Calicut and all. When we reach at Kannur, what is the speed or what is the velocity? Now see the mathematical representation. Can anyone read that? V equal to this point you have to understand. So let it be the final point today. We will read it as V equal to limit delta t tends to 0 delta x by delta t, or else dx by dt. Look here. Are you able to see the graph?
Sir. Yes, sir.
Now, on the graph, consider 2 points. P and P1 and P2. Here. Okay. My aim is to find the velocity at point P. You be very careful about this. This is a good example. My aim is to find the velocity at P. For that, I consider 2 points P1 and P2. What is the velocity between points P1 and P2? You already told. How to find it?
x2 minus x1 by t2 minus t1.
Anakha, correct. x2 minus x1 divided by t2 minus t1. That means slope of the graph. This line. Now be careful. Our aim is to find the velocity at point P. For that, I considered 2 points P1 and P2 and calculated the velocity. Now, what I will do is, I will consider another 2 points. P3 and a P4. Are you able to see the red lines?
Yes, sir.
What is the velocity between point P3 and P4?
x4 minus x3 by t4 minus t3.
Exactly the slope x4 minus x3 divided by t4 minus t3. Now what is the point here is, in order to find the velocity at P, what we have to do is, we have to consider 2 points which are very close to P. What I am doing here, considered P1 and P2 which are far away from P. Then I considered P3 and P4 which are somewhat closer. Like that, 2 points we will consider which is very close to the point P. Then there will be a small displacement and there will be a small time taken for that. That displacement divided by time taken will be the instantaneous velocity. What is the meaning of this delta t tends to 0? Delta t tends to 0 means the value of time is very less. So remember this point, if you want to find the instantaneous velocity at any point, consider 2 points on either side, very close to the point. Then there will be a small displacement, that divided by time taken will be the instantaneous velocity. So today we will finish our session here. Now it's your time. If you want to ask, you can ask. Any doubts or any more explanation? You have anything to ask, or else we will wind up the session. It's your time, 5 minutes. Any doubts? എന്തെങ്കിലും സംശയമുണ്ടോ ചോദിക്കാം. At least you can speak. No one is ready to speak. Everyone kept their phone and doing some other work, I guess. Any queries, any doubts? Okay. If you don't have any doubts, you can leave. Thank you.